Guys, so please bear with me. I understand it may be a little hard to see. I'm trying to make it as best as possible. We are on page 221 in volume 1 of your math book. If you don't have volume 1 because you weren't able to pick it up, that's okay. You can pause this video and we'll gladly let you try to zoom in so you can see it. Message me. I can try to get you what you need so you can be successful. So today we're going to start talking about multiplying whole numbers. Now I understand we've done lots of different methods and lots of different ways. So one way I want to show you, this video is not about necessarily taking notes because this video is a review because we have already multiplied whole numbers this year. So please use this as a guide, as a reference to help you. So here's a little note explaining the area method of how to multiply. It's on page 221. You could use that method to help you, and I'll explain area method in a little bit. Another method we're going to talk about is on page 233. There's all these different methods here. You can look at them and observe them to see how they're working. That's another method we're going to talk about, mainly the old-fashioned method. That looks like about that one. And then the last page is 237. And they show all these other different methods. And then another method that might look a little familiar to you guys as well. So what I'm going to do is I'm going to give you some problems that you are going to need to try yourself. So on page 234, let's see, problem number 4 is 5 times 63. So I have right here, feel free to pause the video whenever you need to so you can see it. I have put here method or area method and how we multiply that problem. So what I would do is I would break it up off 60 and 3, and I put my number there, 60 and 3, and then I put 5 there. I'm then just going to say 60 times 5 and I get 300, and then I say 3 times 5 and I get 15. I add them up and I get 315. Now if I was multiplying a 3-digit by 1-digit, it would look just like this. Feel free to pause this video and use this as a guide. If you ever have a 3-digit by 1-digit, you can use this as a guide to help you. Absolutely. So another way you could do it, which was explained, is partial products. It looks a little bit like this way. So what I've done is I have done the same exact problem using the same exact problem but using a different method so you can decide which one works best for you. Sorry for the video quality, we're working on it. So here you can see 5 times 3 got 15, same thing I did here, and then 60 times 5 is 300, same thing I got there, add it up. Once again, I did 349 times 6, and I did partial products with this as well. You can see I get the exact same answer. It's just a different method. Now the last method and the famous method that we all love is the old-fashioned method. As you can see, I did 63 times 5, just like I did here, and I got 315. What did I do? I said 5 times 3 is 15, so I put my 5, carried my 1. I said 5 times 6 is 30, plus 1 is 31, so that's how I got 31. And as you can see, I got 315 for each method. For my 3-digit by 1-digit, for the last one, I did 9 times 6, got 54. I put my 4, carry my 5. 6 times 4 is 24, plus 5 is 29. Then I did 6 times 3 is 18, plus 2 to get 20. So as you see, all three methods, this method, the area method, partial products, and the old-fashioned method, they all get you the same answer. So what I now want you to do, and feel free to rewind the video if you need to watch it again, not a problem, and you are going to go on page 234, and I want you to finish numbers 5, 6, 7, 8, 9, 10, and 11. I want you to try those. Use any method you want, whatever one works best for you. Try the old-fashioned method, try the partial products method, or the area method. whatever one is best for you. The main goal is to get the problem right, not to get it quickest. It is to get the problem right. Then, after you do those problems, I would like you to go to page 238. And I want you to try just these 3 problems down here at the bottom. It says practice the shortcut method on these problems. You don't have to. If you would like to, you may, but you do not have to practice the shortcut method. Once again, I want you to practice the method that works best for you. If you have any questions, please, please, please let me know. We are not done working on multiplication. We will gladly work on multiplication for the rest of the year.